Hi everyone, welcome to YPRL. My name is Karen. I'm pleased for you to join us. I'm here to introduce Kailash Kalidoss, who is a NASA Solar System Ambassador, and we're really excited to have this special opportunity to connect with him. He's speaking to us directly from the Bay Area in California. So welcome, Kailash.
Thank you so much. Thank you so much, Karen, for this opportunity. And I'm very excited that I can take this NASA Solar System Ambassador role to other countries, especially Australia. And YPRL, thanks to YPRL actually to give that opportunity to me as well. Let's go ahead. And this was actually given by I'm taking most of the materials from the Jet Propulsion Laboratory. And there's a gentleman called Kenneth Wilford who had presented the rover mission to us basically. So I have given him credit because I'm using some of his material in my presentation. So let's begin. This is the first slide. So this is the image of Mars. As we know, Mars is also called the red planet. This is the typical view of Mars you get from Earth on a good day, on a good clear day, when you don't have any telescopes or anything. If you're lucky, you can spot it of this size. If you do have a telescope, that image actually is getting a little bit bigger, but it's also blurry. At the same point, we don't a normal telescope that's available off the shelf is like able to get you to this level of magnification, but still doesn't convey anything great. But exploration of Mars just began like way ago in 1886. So there was this gentleman called Giovanni Scarpelli who actually came up with a map of Martian landscape. And he said that there may be a possibility of streams of water on Mars. So this is the landscape that he proposed. So why I'm telling you all this information is because I wanted to give an intro on the history on which the Mars exploration has been done so far. So it's going back to 1886. So this gentleman from Italy came up with this image. And he also said there may be water on Mars, and that's the quote here. So it may spread to a width of 100 to 200 kilometers or maybe more. But this is just his prediction. This is not reality. So in 1909, there was also a newspaper article by Lillian, which says there would be life on planet Mars, but those were again predictions because we couldn't actually see anything pretty close. And then in 1965, we had the first kind of mission where from the orbiter called Mariner in 1965, which gave the first glimpses of Mars to us. But those images were pretty raw, and we couldn't make much of it either, so we couldn't answer any of the questions. Back in 1975, the Venera 9 went the other way. This is a Russian spacecraft orbiter, which actually went to Venus and checked whether Venus is even close to habitation or not. But they discovered that the surface of Venus is highly acidic, and their spacecraft lasted a few minutes, and it gave these images. The first formal Mars exploration began with the Viking mission in 1975. So using the Viking mission, the Viking orbiter gave some significant images, like I'm going to show you now. And it also had a lander, which showed the surface of the Martian landscape as well. But here came the disappointment. So all the earlier predictions were pretty much wrong. So there were no visual signs of water on Mars. Also, there was no kind of life form on Mars. But our conquest to learn more about Mars kept us going. In 1997, we had the Pathfinder rover delivered by NASA to actually answer our questions regarding the origins of Mars and the suitability of life going forward. In 2004, we sent another rover called Spirit and Opportunities. There are two different rovers sent to Mars on two different locations. basically the idea is to see the origins of Mars. So we now know that there is no life as such on Mars, and we cannot live as is on Mars. So we have to create a life support system. For that, we have to learn how best we can use the Martian environment to actually develop systems that can sustain life in the future. And in 2012, this is the latest rover that's there. It's called Curiosity rover, and this is the rover that's collecting most of the information right now. So to give a history of Mars missions, there are two kinds of systems here. One is an orbiter that you can see, like, which circles the planet around the planet and tries to get data from the top, and then you have the rover itself, where you have an actual landing on the surface of the planet, and the samples are collected at that point of time and to get data. So the agenda has been to follow the water. That's the most common way for us. So if we come to know regarding the origins of water on planet Mars, there was a state in Mars where there was water. So there is evidence of that, but water is not in liquid form anymore. So once we trace the origins, we can try to explore the habitability and seek signs of life. So that's the whole idea. So if you see, we are moving from the left side of the screen to the right side of the screen. And the ultimate goal will be to prepare future human explorers through these missions. So right now we are in the M2020 rover, which is right there in the 2020 column. So we are seeking signs of life. This is the main purpose of mission of Mars 2020 rover. So although we are launching this system in 2020, it's anticipated to land in Mars in 2021, and we have named the rover as Perseverance. This happened very recently. We had a naming ceremony, and then I think an educational institution was privileged enough to actually name it, and a student was his entry won, so hence the name Perseverance. So to give a brief overview, this is going to be a launch system that's going to take place using the Atlas 541 launch vehicle. So July 2020 is the readiness date. We don't have any kind of postponement in sight just because of our COVID situation right now. I think most of the systems are ready to go, and we have a targeted July launch date. So once the spacecraft launches, and then we are looking at around a 7-month cruise, as I said, from July to February. So it's going to take the shortest path that's available to Mars at that point. We're choosing July because Mars is an elliptical orbit, and the distance between Earth and Mars is closest between this time frame. So that's the reason we are launching in July. And then this cruise is now approximately 7 months as opposed to longer when we launch it in a different date. So once we get to the atmosphere of Mars, then we are looking at the entry, descent, and landing criterion. You can see that's a retro rocket system with a sky crane mechanism, which is delivering the Perseverance rover down to the surface of Mars. And as you can see, this system has been tested over and over because Curiosity also had a typical system. So we are not reinventing the wheel here. We are pretty successful with Curiosity. So we're using the same kind of sky crane launching system for the Mars 2020 rover as well. It's been thoroughly tested so that the entire rover lands without any damage. So once we are in Mars with the rover, so the adaptability of the rover comes into play then for the Martian surfaces. So it has a 20-kilometer radius. It's qualified to operate for around 1.5 years, Martian years. It's slightly different to an Earth year. The main mission would be to seek the signs of life. What we're doing here, in addition to what we've done before, is we are trying to get samples from Mars and ship it to Earth again. So that is a significant improvement over other missions. So what we're going to do is we are going to utilize our best laboratories on Earth to do the work rather than the rover by itself. It's a laboratory granted, but its functionality is pretty limited due to size constraints. So that's really a game changer, and we'll get a lot more answers than the previous rover missions this time. So that's something that is unique to the 2020 mission. What are we looking at? Our mission objectives are listed there. They're fourfold. So we are looking at geology, first of all. We are exploring the ancient environment on Mars. We are understanding the process of formation of rocks and other soil elements there, their formation and alteration. And the second goal is astrobiology, where we seek evidence for the past life. This is possibly carried out by carbon dating or say biosignatures that are preserved in the soil. How do you do that? Third objective ties to the first two. So we are going to sample it by actually drilling rocks or collecting soil samples using X-ray imaging that is built into the rover, or laser drilling systems that are there in the rover to collect samples and process and run certain tests within the rover itself. So what happens here is once these samples are collected and tested to one level here in the rover, these samples are archived so that it can be sent back to Earth in a different mission that's going to be carried forward in the future. So by doing all this, what we are doing, what we are answering is how fit the Martian environment is for the human life in the future. So we now know that we have a lot of carbon dioxide in the Martian atmosphere, but we don't have enough oxygen. So one of the things that the rover is doing is, one of the modules that is plugged in the rover is looking to do is like, it's trying to convert the carbon dioxide into oxygen. There's a module for it, which I will talk in the next slide. So typically these are the components in the rover. So most of them are looking at camera, sensors, and other things like X-ray imaging systems. And there is also something called the MOXIE, which I was talking about here. MOXIE is the oxygen manufacturing unit within the Mars 2020 rover, so that there's some amount of oxygen that is required for combustion and other chemical reactions that are taking place within in the Martian surface. Like, to perform certain tests, you do need some oxygen. So that MOXIE module there actually gives you a laboratory method of preparing oxygen using the components that are available in Mars. So that's something we have to look at certain systems like that initially, because we don't have oxygen readily available in the Martian surface as of now. And there are a host of other sensors. There are infrared imaging sensors, temperature sensors, X-ray imaging sensors. You have several kind of radios to communicate things back to the Earth. Then you have other cameras all over. And you have the motion system as well. So it can traverse through any kind of surface. It can climb rocks, it can climb elevations easily. And there were tests that were carried on Earth to make sure that it doesn't get stuck anywhere in the process. In addition to this, is basically carried on from the Curiosity profile. Curiosity was the previous rover. It's still working in Mars right now. In addition to the rover, there is a helicopter as well this time built into the rover. So this helicopter can actually take some aerial views. It has additional sensors, avionics and body. So it has a solar panel that provides energy to recharge its own batteries, and it can get some more information from a height rather than everything from the ground. So this is another thing that is unique to Mars 2020 mission. It's called Ingenuity. and it's integrated as a part of the rover itself. So this profile here is called the Jezero crater, and we are really interested in this site. The reason is because you have a lot of evidence that there was some kind of river or water streams that were flowing at a given time. It's of course there's no water right now, but there's enough data there to tell that there was water at some point of time. So this would be a good place to actually land and look for biosignatures. So this is going to be the landing site. And for this very reason, this has been chosen as a landing site. So what are the science goals? Science goals, as we already discussed, is to determine whether life arose on Mars, how is the climate of Mars right now and how it has changed from before, and what is the characteristics of the geology on Mars to answer these questions. Also, the fourth one is the most meaningful of the three, and it doesn't mean that we can achieve 4 by not achieving 1, 2, 3. So it's like a collaborated effort. Only if you can answer the first 3 can you actually answer the fourth one meaningfully. So I was talking about the sample return. This is not a part of the sample return is not a part of the 2020 mission itself, but what it can be done is future missions can be allowed to land on Mars. So it can rendezvous with the orbiter there and then return the sample through a rocket system separately in the future to Earth. So that gives us a lot more flexibility in determining the geology of Mars and life itself on Mars in the future. So this is basically my presentation in a nutshell. I'd not dwell too much on things because there may be specific questions in the Q&A session. But if you want to know anything more than what I've discussed here in detail, you have the NASA website, mars.nasa.gov/Mars2020. So this is my presentation in a nutshell. Also, I have one final slide talking about the other missions of NASA. So these NASA missions are centered around so many other things. If you consider the Sun, for example, there are these missions like the Solar Orbiter and AS and SET-1 and Parker Solar Probe that is dealing with measuring several entities in the Sun. And then you have the Earth satellites as well, several Earth satellites. You also have the International Space Station where astronauts and scientists actually determine the characteristics of Earth from way above. And we have deep space. We have something to do with the galaxies, and that's a part of the mission that I was invited to. It's called the SOFIA mission, where you can actually determine the life cycle of stars, the ages of stars, and so on, using a 747 flight that flies high above the atmosphere, and then you have an infrared camera in the fuselage. So these are some of the exciting NASA missions, and we are not limited to space. We are also looking at aeronautics and aircrafts and aviation in general, how to streamline aviation, how to make aviation in the future more sustainable. So this is in a nutshell of what NASA is doing today.
Thank you so much. There's a lot of information there, and the graphics are amazing as well. It's a really interesting presentation.
Sure.
Are there any plans to send astronauts onto Mars in a future mission? When how many years do you think before NASA will consider?
So when they drafted the initial plan in 2012, so they planned a manned mission to Mars by around 2025. But I don't think we are going to hit that 2025 target the way we are going right now. We have to first achieve the Artemis mission. The Artemis mission is the first manned mission to Moon after all these ages. They're going to go and set up a base in the Moon, in the Earth's Moon. So that's going to be the next major challenge for NASA. They're preparing that as a part of even this SpaceX launch, where they're trying to send the astronauts outside the Earth atmosphere and let them acclimatize in the International Space Station first. And the next major step is going to be to set up a base in Mars. I mean, a base in the moon, so that we can use that as an intermittent base to launch to Mars.
It'll be closer. Is it?
Yeah.
Yep.
So we have, in fact, Artemis program is running full scale now. NASA is recruiting new astronauts, and this mission is going to be the next manned mission to major manned mission that's going to happen in NASA. And we are going to, the idea is to use moon as a base.
Okay. Oh, we'll look forward to it. That sounds interesting in itself. I think building a base and using that to do other projects will be amazing too. Well, thank you so much for the opportunity to connect with NASA and connect with you again. It's been a real pleasure and so exciting.
Thank you. Thank you so much.
Thank you so much.